All right, today's lesson, lesson 67. We are now going to look at graphing the logarithmic functions. Okay, again, first part is review of what we did yesterday. Okay, your exponential functions, y equals b to the power of x, and your logarithmic functions are inverses of each other. Again, how do you find an inverse? You switch x and y. So, given the exponential function with the example of a base 2 would look something like this with a horizontal asymptote. Your logarithmic function, when we switch x and y, will now look like this with a vertical asymptote. Instead of going through the point 0, 1, your logarithm is going to go through the point 1, 0. And again, notice they both have a base of 2. It could be whatever base, but that's the example I'm using. Whereas your exponential goes through the point 1, 2, your logarithmic would there go through the point 2, 1. So on and so forth. So just simply switch the x and y. So with that in mind, I would begin with the exponential functions. So y equals 4 to the power of x. Not worried about any shifts at the moment. I just want to start with the basics. Through that starting point, we have a horizontal asymptote. Since the base is 4, which is bigger than 1, I know it's going to be an exponential growth function. So we start with the point 0, 1, and then now with the base of 4, it's going to be 1, 4, counting from the x. The next one would be 2, 16, which is way off the graph, so these are all the points I need. This comes out this way, we're chasing that asymptote, and that is that graph. Whereas number 2, my base of 1/3 is smaller than 1, so it's going to be exponential decay. It is still an exponential function. It is exponential decay. Goes to the point 0, 1. Now, 1/3 would be similar to the base of 3, but instead of going increasing, it's going to be decreasing. So in other words, I need to go left 1, up 3. My next point would be left 2, up 9. Right. Now that's review. Those are your exponential graphs. Now, what we are really doing today are the log graphs. Now notice, I'm trying to get it where I can see both, can't very well. But whereas this was exponential base 4 and exponential base 1/3, now I'm going to do log base 4 and log base 1/3. So they are simply the inverses of the two graphs we just did. So if you wanted y equals log base 4 of x, you could rewrite it in exponential form. The base of the log is the base of the exponential. What the logarithm equals is the exponent, and that equals the argument. So x equals 4 to the power of y, if you want to make an xy table and plot points and graph it that way. I don't, but that is an option. What I do, I simply think of the exponential. Y equals log base 4 of x. I'm going to think about y equals 4 to the power of x and know that that is not the correct graph. That's the exponential graph. But if I just simply switch the x's and y's, I will get my logarithmic graph. Starting point is still at the origin. But instead of a horizontal asymptote, my logarithmic graph will have a vertical asymptote. Whereas my exponential graph would go through the point 0, 1. My log graph will go through the point 1, 0. Once again, my exponential graph goes through the point 1, 4. So that means the log graph, switch x and y, would go through the point 4, 1, counting from the x. My next exponential point would be right 2 up 16, which means my log graph is actually right 16 up 2. It's way out here. Not going to worry about it too much. But it's going to come like this, and again, it is chasing the asymptote. And that is my quick sketch quiz. Number 4. Y equals log base 1/3 of x. There is no shift, so we're going to start at the origin. Through that starting point, we have a vertical asymptote. Now, whereas my exponential graph would have started at the point 0, 1, then that means my log graph is going to be at the point 1, 0. Now, the exponential graph then went left 1 up 3. So negative 1 comma 3. That's my ordered pair. Switch x and y, that means my logarithmic graph is going to be 3 comma negative 1 as the ordered pair. So it's going to be that point right there. And then the next ones were off the graph. So I'm not going to worry about them. We have that right there as our quick sketch quiz. Alright, and then like after that, it is simply a quick sketch quiz. So all the same rules of everything else we've been doing all year. So number 5, this graph is shifted how? That right there would tell us 2 to the right. So go 2 to the right. There's my starting point. From that starting point, I have a vertical asymptote. And then now it is simply the y equals log base 4 graph. So again, I would be thinking about y equals 4 to the power of x to do my exponential, and then I change it to the log graph. So whereas my exponential goes to the point 0, 1, the log graph goes to the point 1, 0, counting from that x, that starting point. My next key point for the exponential would be 1, 4, which means the logarithmic is 4, 1. And we have our graph. Next one, again, y equals log base 1/3. But now we are shifted 1 to the left and 4 down. So 1 to the left and 4 down. That makes our starting point there. Through that starting point, we have a horizontal asymptote. Instead of going through the point 0, 1, we're going to go through the point 1, 0. Next point my exponential would go through would be negative 1, 3. This one would go through the point 3, negative 1. Again, make sure you count from the x. Next one would be negative 2, 9 here, which makes the log graph 9, negative 2. That's a couple of points off the grid that I'd probably extend it. And there's our graph. Next one, let's change this. Y equals negative log x. So then the question is, what is the base, since I did not write one? Okay, this would be base 10. If there is not a base written, it's a common log. So this is log base 10. What does the negative do to the graph? Simply flips it. It is inverted. Okay. There is no shift, no manipulation, so we're still starting at the origin. It is a logarithmic graph. Logarithmic graphs have vertical asymptotes. Now, that's what I'm going to think about to start with. And from there, I go to this, and then I come back up here to that. So, whereas this graph here starts at the point 0, 1, and I would make this graph here 1, 0. Now that negates the y value. Well, it's still going to be 1, 0. Next point with this one would be right 1 up 10. So the point 1, 10 makes my log graph actually 10, 1. Put the negative up here in the graph, flips it to actually be 10, negative 1. So I got 6, 7, 8, 9, 10, negative 1. Next graph has all kinds of manipulations involved. Start with, just know we are shifted left 3, up 2. So left 3, up 2, that is our starting point. Through that starting point, I have my vertical asymptote. All right, and we're going to have all kinds of manipulations. Let's see. I'm trying to decide if I want to go how in depth. Let's just start this way. Y equals 5 to the power of x becomes y equals 1/5 to the power of x. This becomes y equals log 1/5 to the power of x. That then takes us to y equals negative log 1/5 to the power of x. Lots of flips. If you so desire to do it this way. If you've got another way that works for you, do it. This is what I do. It is a bunch of flips, but it works for me. All right. This graph would start at the point 0, 1. So with this one. Now, going from the exponential to the logarithmic, you switch x and y, so that means this graph is 1, 0. Now the negative switches the y value, it's still going to be 1, 0. So I'm at that point. Now, back to my original exponential, this would be right 1, up 5. So the ordered pair of 1, 5. Now, when I switch my base to 1/5, now it's left 1, up 5. Switching to a logarithm, switch x and y, so now we're at 5, negative 1. And then when I negate the y value, now I'm back to 5, positive 1. counting from my x. 1, 2, 3, 4, 5, up 1, and we are right there. Now, it is important to note that yes, that is the exact same graph that you would have got had it been simply y equals log base 5 of x. Just so happens that the base of going from a base 5 to a base of 1/5 flipped in the y direction. And then the negative flipped it in that y direction again. So since you flipped it in the y direction, flipped it again, they basically cancel each other out, and you end up with the same graph. Okay. It's kind of one of those weird things that happens with logarithms, but if you were looking at that being a little bit confused, you're actually not confused. You are correct. All right, 2 more. Number 9. Left 4, down 6. That's your starting point. Through that starting point, should have a vertical asymptote. Okay, now it is a log base 2 graph. So let's start with that one in my head. So whereas this goes through 0.01, my log graph is 1, 0. Whereas the exponential would now be 1, 2. The log graph is going to be 2, 1. Next exponential would be 2, 4. Making the log graph 4, 2. Next exponential would be 3, 8, making the log graph 8, 3. So I have several points this time. Still needs to be chasing an asymptote as I go off the edge of the graph. And there is our quick sketch quiz. Alright, and the last one. Natural log graph. Okay, that plus 3, it is not in parentheses. So it is not grouped with the x. It simply means up 3. Vertical asymptote. And now our natural log graph means log base e. So I'm going to think about y equals e to the x. So the exponential would be 0, 1, makes my log 1, 0. Now, e is approximately what? Okay, 2.7. So whereas this would be right 1 up 2.7, my log graph is going to be right 2.7 up 1. And that is all we're going to worry about. Alright, we're not finished. We need to go back and let's look at our domain and range and even the asymptotes. So, let's go back to problem number 3. What is the equation of our asymptote? Okay, the equation of the asymptote, well, it's a vertical line. Okay, vertical lines cross the x-axis. Where does it cross the x-axis? At 0. What is its domain? No, it doesn't go left and right forever. It starts right here at 0 and everything bigger. So my domain is the set of all x such that x is greater than, not greater than or equal to, doesn't touch that asymptote, just greater than 0. What about the range though? Well, it definitely goes down forever. But even though it's going mainly to the right, it is still going up forever also. So my range is all the reals. Okay, note that that is a switch of what was going on with my exponential graph. With my exponential graph, the domain was all the reals, and the range was bounded by that asymptote. But again, they're inverses. You switch x and y, now we have your domain and range getting switched. Alright, let's just jump down to number 8. Quick one, that was number 8. So what was the equation of this one's asymptote? Okay, it crosses the x-axis at -3. So x equals -3 would be the equation of your asymptote. Domain, set of all x's such that x is greater than that asymptote. Starts at that x value of -3 and everything bigger. Range, on the other hand, goes up and down forever. So my range, all the reals. Alright, and that is today's lesson. That is lesson 67, graphing your logarithmic functions.